Addition and subtraction of algebraic fractions. As with numbers, adding and subtracting fractions is harder than multiplying and dividing fractions. It involves a lot more work because you've got to change the denominators to be the same. So we're just going to go back over what we do with just normal numbers. So 1/2 plus 3/5, we need a common denominator. We look for the lowest common denominator. That's going to help us in algebraic fractions. So we're looking for the smallest number that 2 and 5 go into, which happens to be 10. And then we change each fraction into an equivalent fraction. So 1/2 changes into 5/10, and 3/5 changes into 6/10. We can see that we did that by multiplying. What do we have to do to 2 to get to 10? We need to multiply it by 5. So 1 times 5 is 5. To get from 5 to 10 we need to multiply 2. So 3 times 2 is 6. And we add it and we get 11/10. Easy algebraic fractions. We have 2/3a plus 3/2a. In this case we're looking for the smallest term that 3a and 2a go into. So we're looking for the lowest common multiple. In this case it would be 6a. Notice we don't multiply the 3a and the 2a together and get 6a squared, because there's something smaller that a goes into than just a squared. It's just a. So don't fall into the trap of multiplying all the denominators together, because that would can make a very complicated fraction. So in this case we're looking for the smallest thing that 3a and 2a go into, which is 6a. So here 3a, to get to 6a we needed to multiply it by 2, so we get 4/6a, and 2a to 6a we needed to multiply it by 3, so we multiply 3 by 3, we get 9, so we end up with 13/6a. So you need to be writing all of this down, including these notes here. So please, if you haven't written the above examples, it would be a good idea to go back and do that, just to revise and remind you of what we do with the common denominator. Okay, so the notes about adding and subtracting. We need to factorise the denominator of each fraction. Factorise the top if there's, because that could be useful and make things easier, but it's the denominator that we're going to be more concerned with. So factorise the denominator of each fraction. Find the lowest common denominator. So we're looking for the lowest thing that we're going to get with the denominators on the bottom. So you're not multiplying them together, because you might not have to. There might already be terms in both of them. So let's just think carefully when you're coming to find the common denominator. Then we rewrite each fraction with this common denominator and simplify. So that means that we're rewriting equivalent fractions. Okay, we're not going to write them in two totally separate fractions. We're going to bring them together. You just need to be careful if you're working with minus signs, and we'll come to that when we do a couple more examples. So in this case here, we've got x plus 2 and x plus 3 as our denominators. The common denominator here is going to be multiplying them both together. There's nothing common between these that we can use, so we need to multiply them each together. So this one here, what it's missing on the denominator is the x plus 3. So I need to multiply this whole fraction by x plus 3. Okay, so we end up with x plus 2, x plus 3 on the bottom. And this fraction here, what don't we have? We don't have the x plus 2 on the bottom, so we need to multiply by x plus 2. We then expand out 2x plus 6 plus x plus 2, just expanding the brackets. Collect the terms. Sometimes there might be something to cancel out. Be very careful with that. And that ends up being our answer, 3x plus 8 over x plus 2, x plus 3. Leave the denominator in factorised form. There's no need to expand anything out. All we're doing here is expanding to collect the terms. Okay, so that one was pretty straightforward. Number 2. Okay, in this case we've got a subtraction, so we need to be careful. Again, we have nothing in common between the two denominators. Okay, 2x plus 1, 3x minus 1. It's like having a 4 and a 5 on the bottom. Okay, there's no common link between them. So 4 and 5 you multiply to give 20. So here we just multiply the denominators together. And in this case here, what we needed in the first fraction was the 3x minus 1, hence 3 multiplied by 3x minus 1. And in the second fraction, we're missing the 2x plus 1, so we put the 2x plus 1 in the bracket there. Denominator, once we've got the common denominator, it just follows through. It's now the numerator that we're going to be working with. Be careful when we're expanding. 9x minus 3 minus 8x minus 4. So be careful when you're expanding, when you've got a negative out the front, everything inside is times by the negative. Bring everything together, we're left with x minus 7 all over 2x plus 1 multiplied by 3x minus 1. Okay, now these questions are now going to involve factoring. So we need to factorise the denominators. So in the first fraction, it's just a normal trinomial. It's going to break up into x plus 3 times x plus 2. We now look at the fraction as we've got it here. As you can see, we don't have to multiply 3x plus 3 times x plus 2 times x plus 3 and have 3 terms on the bottom, because the x plus 3 is already part of both the denominators there. So our common denominator is going to be x plus 3 times x plus 2. So this fraction here we don't have to do anything with, because we've already got the correct denominator that we want. So it's just 1 plus the second fraction. What are we missing? We're missing the x plus 2, so the x plus 2 goes in there. We expand, collect the terms, and the answer ends up being 2x plus 5 all over x plus 3, x plus 2. Okay, make sure you're copying all of these down and understanding them. Ask me any questions in the next lesson. Okay, let's try another one. They don't really get any more complicated than that. It's just that you have to probably factorise a bit more as we go along. Just be careful with your signs. So here we've got 4 over x squared plus x minus 3 over x squared minus 1. Take out any common factors, factorise the denominators. So take out a common factor of x, leaving us with x times x plus 1. In the second fraction, it's a difference of 2 squares, so x plus 1, x minus 1. We already have x plus 1 in both of the denominators, so we don't need to multiply by it twice. So we've got x plus 1. The only thing we need here is the x minus 1. Here we've got x plus 1, x minus 1, so the only thing we need is x. So here, the first fraction, we need to multiply by x minus 1, and the only thing we're missing for this fraction is the x, so it's 3x. We expand out the numerator, 4x minus 4 minus 3x. Collect the like terms, we end up with x minus 4 all over x times by x plus 1 times x minus 1. Again, fine to leave it like that. Don't worry about expanding out the denominator. And also, very carefully, do not think that you can cancel out those x's. You can only cancel out things that are multiplied. And the x is not multiplied here. The x belongs with the minus 4. Okay, let's have a look at number 5. Okay, x plus 3 all over x squared plus 2x plus 1. Take away x minus 1 all over x squared minus x minus 2. Factorising both denominators, we end up with the denominator of x plus 1, perfect square, and x plus 1, x minus 2. So our common denominator is going to be, well, here the only thing that we haven't got is the x minus 2, and here we need to add in another x plus 1. Okay, so everything here and the x minus 2, everything here and another x plus 1, because they have to be common, they have to be the same when we change them. Okay, so what was we missing here? We were missing the x minus 2. And what were we missing on this fraction? We were missing another x plus 1. Make sure that you can see how that works. We're expanding out the answers here. So we're expanding that out to get x squared plus x minus 6. Make sure you understand where that comes from. Minus, this is a difference of 2 squared, so that's x squared minus 1. Just make sure you're happy with that as well. So when we go to expand that out, that becomes minus x squared, so the x squareds cancel. That becomes plus 1, so we've got x minus 6 plus 1, x minus 5. And we haven't expanded this out, but we've just seen that these are the same thing, so we can write it as a squared just a little bit neater. Okay, you've got questions that you can go on with. Okay, thank you.